That video went away. So I think we're live. At least I hope we are. It's 8:43 p.m. on January 4th. That video went away. 2023. So I think we're live. At least I hope we are. I can't believe it. It's 8:43 p.m. on January 4th. That video went away. How are you doing? So I think we're live. At least I hope we are. I can't believe it. It's 8:43 p.m. on January 4th. That video went away. How are you doing? So I think we're live. Joining us. I hope you are. It's 8:43 p.m. on January 4th. That video went away. How are you doing? I think we're live. I hope you are. It's 8:43 p.m. on January 4th. How are you doing? It's hard. I think we're live. Talking about private it's hard. I think we're live. Talking about private no idea what. It's hard. I think we're live. Talking about we as developers no idea what. Play our app and get it going. I think we're live. Get it out there publicly. But we as developers no idea what. Play our app. These are concepts that I knew that you're publicly. But we as developers probably play our app. These are concepts that I knew that you're publicly. Is it really protected? And these are concepts about that. So I was recorded, right?
Yes.
Is it
we
really
did
protected?
we captured that part.
And these are concepts about that. So no, I was recorded, right? And in fact, I know is it
we did
protected?
capture that part.
And no, I was recorded, right? And in fact, I know
we did
protected. It is protected. No, I was recorded, right? And in fact, I know protected. But it is in fact,
I am now on my own. You might be hearing Chris in a little bit. I am now on my own in the same room. You might be hearing Chris in a little bit. I am now on my own in the same room. You might be hearing Chris in a little bit. I am now on my own in the same room. Those are the things you might be hearing Chris in a little bit. I am now on my own in the same room. Things that those are the things you might be hearing Chris in a little bit. I am now on my own in the same room. Things that which is great because the things that are a little bit are why which is great because the things that are a little bit are why which is great because the things that are jump into session here. Yeah, we got you now. Great. It's funny, we're in where the old studio session here. Yeah, we got you now. Great. It's funny, the old TriCap in where the old studio session here. Yeah, we got you now. It's funny, the old TriCap in where the old studio or at least the shades up here. Yeah, we got you now.
That's true.
So we really didn't need that TriCap or at least after all that time. Yeah,
we had a comment. Somebody said the audio was looping.
So we really didn't need
I'd be
that.
curious if that's still going. And I think the reason might be that we had a comment. Somebody said the audio was looping. We would be curious if that's still going. And I think on my lap, the reason might be that we had a comment. Somebody said the audio was looping. We would be curious if that's still going. And I think on my lap, the reason might be that we had a comment. Somebody said the audio was looping.
It is.
We would be curious if that's still going. Oh, is it? And I think on my lap, the reason might be that we had a comment. Somebody said the audio was looping.
It is.
We would be curious if that's still going. Oh, is it? And I think on my lap, the reason might be that I had a comment. Music is off, maybe. But we are in a loop. In other words, when we talk.
It's Sounds good right now. Let me bring up the YouTube. Trying to figure where the system stuff came from.
Okay, so it's okay now.
Really?
So
Okay.
it might have been. I think what happened is when StreamYard kicked me out, I don't know that it turned off the audio loop that plays when the show before the show starts. That probably played over the show
Intro?
video. Well, you know, whatever. We're we're learning. So because this is definitely new territory where we're both remote. And working through this. And I also don't know if we're picking each other up on the mics. Let's hope that that's not happening. But in any case, but yeah, we had a good night here. In a couple weeks, Philly.net will be here, and there is a Philly Code Camp planned for April 1st, and that's not a joke, or the joke's on us, one of the two. And there will be more information about that if you happen to be in the area and you're missing the old Code Camp days. But tonight we were going to have a short show that came about missing the old Code. I asked a question that was, this was the question I asked was, are we stuck with REST APIs for microservices? Like that was just a pondering of mine. Are we really stuck with that? Can we go no further? And I'm not here to complain about it, but that got us onto the larger topic of the microservice is an easy word to say. We all throw it around. And to be fair, there's probably a lot that we all need to learn, but yet jump into the deep end of the pool anyway. So we thought we would talk about it a little bit, and I certainly have a lot of things that I think about that I wonder how well we are at doing. Just for example, it sounds easy. It sounds easy, right, Rich? Is that we used to build, maybe we built some, we call it the monolith, maybe it was an executable, or it could have even been, even in the days of the web application might go back to the database on its own, and who knows, and heck, even if it had a business layer in between, that's a far cry from a microservice, just because you might have put some API between you and the database. I mean, that's not really a microservice. So I guess the first question was starting to think through, when we say we're going to use microservices, what are we committing to that is not the monolith way, right?
Yeah, and oftentimes that's how we start, right? You've got that monolith application, and there are plenty of, we can throw some links in the chat, but there are plenty of architecture patterns out there that use that monolith description as a way of describing where you are now and then what you want to get to, about breaking the services apart and making them, breaking them apart so they are more consumable, so they can scale better, so that you can update them better without having to completely, redeploy the entire application, which is the thing that we're trying to get to, right? Make these components essentially be things that we can deploy on a much smaller scale, and then scale them out as well. But I think if we go back to the first question you kind of lead it in with, do they have to be HTTP? No, they don't. And I think when we think about microservices, we certainly think about APIs, we think about REST communication, and having that all happen over HTTP. And one of the common things that winds up happening is, well, as I start to break out my application into various services, I might just continue that HTTP conversation to communicate with all of those individual services. And if you do that, then that winds up being like a synchronous type of communication, right? I'm going to have an orders API talk to a products API, talk to a billing API, and be able to have all of those things assemble what needs to be included inside of my order. And that's pretty much an anti-pattern when we think about microservices, right? We don't want to link all of those synchronous components together, although when we think about HTTP communication, that's typically how that works, right? But we can certainly have other types of asynchronous protocols, things like AMQP as an example of that, or being able to include a messaging component inside of your somewhere as part of your infrastructure. So you might have that first call that says, hey, I'm going to go place that order. And that's great. The order's captured and it's going to go through its process to get fulfilled. But you might have other asynchronous bits of communication that then go ahead and update the products or make sure you've got adequate quantity to fulfill that order, go through the bill and go through the credit card components. Because if you think about it, on many online services, when you do that kind of click the button, those services happen behind the scenes. And even though it says, hey, we've got your order, we're going to take care of it, there's back-end processing that happens. So it could be a bit of a, it could take a few minutes for all of that comes together. And then it also could come back and say, hey, we kind of made a mistake, we're one short, or we're whatever it might be.
Yeah. And then from the software point of view, I think, like you said, is I don't want, I mean, this sounds very primitive, but of course this is how things used to be built, is I don't want, when I click the button on the website, I don't want it to call out to the product inventory and confirm that it's there. And then maybe it does something to like lock it, or I don't know.
Right.
And then it makes another call to set up shipping and another call to do the credit card. So instead it's to say, I think you said it, you mentioned AQMP, like a queue-based system, but I think what you're saying kind of is that from an abstract level, we want to think of this as a message, not as the operations to be done.
Right.
The front end, this web page doesn't actually care. It needs to know it needs to have something to tell you. Like when I hit the e-commerce site, I'm expecting an answer, and I would like for it to say your order was received or congratulations, or and I suppose if your business processes are good enough, you can make a lot of assumptions that this is probably going to work and the user is probably going to be happy, but stuff is still happening, I would think. I would think that I just don't feel like that's all instant. At least if it was, then, well, that leads to several problems. How much can your site scale if you really are making sure that you've gotten the credit card funds and you've made sure the order's there and you've set up the shipment? So it can't scale that. It can't handle too many orders at once.
Right.
And then second, and it was something you said at the beginning, breaking apart an application so we don't have to deploy it all at once.
Mm-hmm.
So if these things are connected, not just in code, but by design and the concepts of each of these processes, then somebody comes along and says, oh, we had to make a change to the credit card processor. Who knows why? It might not even be your fault. It could be that the software's changed.
Right.
But in order for the rest of the app to work, we got to shut the whole. Maybe that's where things like server maintenance came from, because we got to shut the whole thing down.
Because that's what we do to do those kind of.
I mean, we still do.
Right? Yeah. To some extent.
Downtime is still hard to avoid, but I guess part of what I'm thinking now is it sounds like, oh great, well let's just break things apart, but that's the real trick.
Right.
And I wonder, we were talking before the show, is where do you start? What's the first place to start? If it's hard to use a business example, I suppose. It's easy to go to the e-commerce type site where you have orders and inventory and products and shipping and customers. But I feel like the first place to start is what is the, forget all the technology, forget how people are going to interact. Just what's the data?
Right.
Yeah.
And that's an important concept when we think about microservices, because we can, as developers, we can think about, when we think about that microservice, it essentially needs to be, its own, it has boundaries around it, right? This component that makes up our microservice, whether it is our, um, you know, and, if we're talking about order processing, we're talking about conferences or what have you, right? There are certain domain components of your data. So if we look at, we look at a conferencing app, let's say, and there's a certain set of APIs related to getting it for registering for that conference, and there's certain APIs that are related to the actual getting collection of talks for that conference, and then for the day of the conference, while the conference is going on, how do I get the information on what talks are happening now and what speakers are there and those kind of things. Each one of those potentially can be its own separate microservice because it can live and scale. It can essentially be updated and maintained and deployed in and of itself, each of those kind of four main components that I talked about there. It also has its code that needs to be integrated and tested and deployed. What's also important inside of there is the data. So there's data that's associated specifically with that one portion of the application, whether it's the registration for the conference or the getting of the speakers or the actual information that happens on the day of. And the reason those are different data elements is because they essentially have different data models. When we go through the life cycle, as it were, of a conference and where APIs might be feeding that information back to the applications that are calling it. So it's not just the code that has to get brought up, it's also the data as well that needs to be able to be deployed and maintained and managed independently of all the other services. And if we can do that, then we've kind of gotten to the point where we've separated, we've defined our microservice in such a way that it can be separate and do those things and live on its own almost. That doesn't mean there aren't components of a model that exists throughout all of those APIs I talked about. So if you think of the one thing that kind of goes across all of those is the conference goer. So the conference goer has, they're going to register for the conference. Well, there's one set of data that's specific to when I register for a conference versus when I'm actually attending the conference, or when I go ahead and do my billing component of that. So while it might still be the quote-unquote attendee, there's different data model structures, different properties that are associated with those APIs and the underlying data sources that support them. We kind of said a lot there, and I'm sure there's a bunch of questions and comments, but I'm not looking at the chat.
Yeah, well, so just thinking through what you said, so let's say we're going to write an app that manages CodeCamp. Look, people are in this business already.
Yeah.
And you mentioned it. You mentioned that there's attendees that want to register, and then they're going to show up day of. There's sessions, there's speakers, there's organizing that into an agenda, displaying that agenda. You could do a great job of segregating that data. In fact, if we go back a little ways, maybe you even are using a relational database and it's in third normal form, all that stuff. It's really good, but it still doesn't have to be a microservices app. Like, you've done a great job segregating the data,
Mm-hmm.
but you still deployed an app that actually hits the database.
Right.
You've done a great job, but I feel like the key difference is in the microservices approach. We're going to now identify a service, and I'm trying to figure out what maybe one of the first easy ones is. You kept talking about attendees and registration.
Mm-hmm.
Are those separate, or is the function of registration part of a service that deals with attendees? I hesitate to just put a stake in the ground and say there's an attendee service. But that's one thing we got to do. People have to sign up, and then I know I can think of other things I'm going to need when they show up. I'm going to need someone to be able to just to keep it simple. You say your name, and then I'm going to look you up. Well, that's probably coming from the same service
because it's related to your registration, right?
Right.
But so that that person who registered for your conference or what have you you can almost think of them as your customer. They're coming and buying a product from you, so you could almost identify them as your customer, your buyer, whatever it might be. If you think about them from the payment side of things, they're actually the payer component. They've got their credit card information over there, and there are different properties than what it took to go ahead and register into your application. Even though I'm sure that there's a credit card component of that registration. If they're talking to customer service, because you might have a customer service component in your API, they're customers at that point. Going back to that same idea, just a little take on it. When they actually get to the conference, they're users, right? They are attendees, whatever, however it is we want to classify it. But in each one of those, what we're interested in around all of the different things that make up that person throughout that entire journey, there's only certain parts of those properties that we're interested in at any one of those points in time. And because of that, that's why we can separate out the data, we can separate out the services components.
Okay, so yeah, there's a person, there's some entity, an attendee, who has to sign up, they get to attend. But I feel like what you're telling me is there's more. There isn't just one service. There's a service that knows how to, when they've provided us with credit card information, because maybe it costs money to attend,
Mm-hmm.
it goes and retrieves the funds. So that's getting. Is that all that thing does?
Yeah, I mean, you might have something that's because it's you could then reuse that for any time you have to invoke anything that relates to a payment, right? We're at a conference and we're selling T-shirts at the conference.
Okay.
We're selling swag. I can still use that same payment service as part of that process at the conference. Then as much like I did at the registration. So that's why you might want to pull that out and just let it focus on the what was that thing? The single responsibility is, as much as you can do that in this kind of a scenario.
Okay. Now this domain of the attendee, they've got a name, and then we've established they have a credit card.
Mm-hmm.
But not every service is interested in all of these things.
Right.
For example, the payment processing doesn't actually care so much about the attendee. It's just there's a message coming to it saying, like, in order to do your job, you happen to need to know some of the same things. But that's just a function of when you do a credit card purchase, you usually have to know a name, and you usually have to know something like maybe a zip code and maybe the little number on the back.
Yep.
I almost consider that kind of a coincidence, because if the credit card company asked for something else, then we might not care about the attendee's name. In fact, you could find this in other forms of payment. Maybe they asked for a token.
Right.
So I still don't care about that person. So I guess what I'm getting at is that I keep wanting to come back to this list of attendees, which maybe is a service, in order to do several things. It's in order to sign them up, and to put them on the list of people that are going to attend.
Yeah.
But that list also doesn't care if it's a free event or paid event. It doesn't care.
Right.
And you said something interesting. Maybe you have merchandise at the conference. Wouldn't it be cool if the person at that little desk,
Mm-hmm.
they when you come up and say, hey, I would like to order a shirt, and you say, well, hey, you're an attendee here, what's your name? And your address is there. And say, well, would you just like it shipped there?
Right.
So this app is getting that from an attendee service? Maybe?
Yeah. Probably from some kind of
an attendee API?
Yeah. I mean, maybe a conference management type service, right?
Okay.
Because these are the things that I need to be aware of as I'm running my conference. And again, that's, that might be your core CRM if you think about your customer. And these other services, well, this conference is I have to order or I have to register and order tickets for that one versus, hey, this is just an online one and there's no ordering going on. I may still have to order, so that they know how many people are here, but so that process of ordering has a defined life cycle for it, right? I'll do it once at the beginning, but I probably won't go to it again throughout the course of me attending this conference. So that's why it can be broken apart and separated out from some of the other core services, like the conference management piece that has main information about me, about my address, my phone number, how I like to be contacted, what my interests are, those kind of things.
Does it also have your credit card information?
No, because that would be, and I think you were kind of hitting on the head, you don't really have, as an organization, we really don't want to hold credit card numbers. We want to be able to say, go here. When you're done, I'll get the token back, basically, that says, yes, your credit card stuff worked, and I'm going to get paid when all your accounts receivables happen.
So let me come back to that because we got a couple interesting questions.
Because I can't see chat at all.
Yeah. So can you see what we're putting on screen?
Yeah.
Okay. So Rich Corkery says, in the payment service example, what's the difference between a microservice and an API? And that I found that interesting because I kind of was, as we were sitting here talking this through, I said, okay, I can envision myself calling an API that's something / attendee, and then it might be something you use to search by name, or maybe it's an attendee ID number. 5374 is you, Rich.
Right.
And I don't know that, but on my screen up comes, let's go back to, we're talking about the t-shirt booth.
Right.
I'm running the conference. I'm an authorized vendor. It's a cool t-shirt for the conference. And I'm trying to figure out how these things are getting reused because clearly they already are. I needed that attendee service when you checked in. I needed it when you registered. And now I need it again. And the reason why I think I need it again is because I don't want to ask you where you live. If you maybe supplied that already, I might just say, hey, is this a good address to send this shirt to? And you say, yeah, that's great. Like you already have it. So now I'm actually kind of, the API is the front end for the mic for a service, but it doesn't have to be one-to-one, I don't think.
No, I would say that's fair. It does not have to be one-to-one, right?
Yeah.
There might be multiple APIs that microservice includes or needs to talk to be able to fulfill whatever that request is that it needs. So,
because you're kind of heading towards a conference management service. That's what I've heard you say that a couple times, and that might include an attendee's API.
Yeah, and I think maybe try it this way.
Yeah. Okay.
So think of a microservice as, and there's a couple of different technologies and terms that we might consider or get tightly bound to the term microservice, right? Whenever somebody thinks microservices, we often think of things like containers, right? Or we think of APIs. And yes, those are certainly components of it. But microservices is kind of the architecture, and the API is a bit of the implementation, right? So we can have a microservices architecture that has discrete sets of services that have their own data, that can scale independently, that can be updated, tested, and deployed independently of the other microservices that are in our environment. We can architect an application that way. How they communicate could be through APIs. It could be through messaging. It could be through gRPC, right? There are different types of way of communicating and having the microservice fulfill the needs that it needs, or the services that it is providing to the underlying applications that are calling it. So I think that one is an architecture and the other is an implementation within that. So that can be part of that architecture if I had to, compare and contrast the two.
Yeah, I think you make a good point, and again, it's interesting to think about because it's super easy for us to watch like a demo of somebody using Kubernetes and saying like, all right, and because how does that demo look? The demo is always like, well, we built some web API and then we deployed it. There it is, the microservices live. And it's like, wow, that's really contrived.
Okay, but we have to contrive it a little bit to make it visible and tangible to people to understand what it is that we're trying to put in place there.
Yeah. So another question that was asked was if I think I'm going to just presume that it's if I have a payment API, is that a microservice? And I think that's kind of what we're saying, is that not necessarily, because I could build an API that's clearly not a microservice.
Right. And
But yeah.
go ahead.
Well, I could do that. And then this sort of leads back to something. So in my fictional example, you got in here somehow, and then you came to my booth where I'm selling t-shirts, like I'm just working here.
Mhm.
And you said something really interesting, because I wanted this service to wake up and put on my screen for me, who you were and where this might ship to. And I'm thinking of that as a convenience to you. And then I get to use my front end here to also pick what you're buying. That sounds like a whole other set of services.
Right.
But then you said something interesting. You said we don't want to own credit card data if we don't have to.
Mm-hmm.
And I think you're right. Like that's the whole point of services like Square.
Right.
When I'm out there in public and I'm seeing everybody, in fact, we're even seeing like retailers doing this now, where they're just putting that thing up because clearly they don't want to own it anymore.
Yeah.
They want me to I own the card and I tap or insert or use it. I own the transaction from beginning to end. They're printing nothing out. They're storing no receipts. But to be a little fair, and maybe that's the best news for most of us that are watching.
Mm-hmm.
But when you're a big, huge retailer, I'm still putting credit card information into those sites and they're still keeping it. And so somebody's still doing it. And it may just be because they're the big, huge, or maybe they just haven't figured it out yet. I don't know.
I mean, it's by choice, right?
Sure,
I mean,
it's a choice that they made.
Did an order at a site this morning, and I put my information in, and although I had an account there, they did not have my credit card. I put my credit card info in, and I hit. There's a option to say, "Do you want us to keep this?" And I unchecked it. And I said, "No, this is just for this transaction. Don't worry about storing this. Move along."
Yeah,
that's
use it.
Typically how I do
forget
it.
Yeah. Yeah. Which so it's interesting. We got a great feedback from ContriveDX. To me, some of the main tenets of microservices are redundancy, discoverability, own their data, and automated deployment. And I bet you we could find a bullet point list like that. It's great. I appreciate that. That's a good place to start. And that's certainly true. The reason why I can leave it up. The reason why we like this model is because it's a little easier to provide high availability redundancy when you're not trying to keep this whole thing up, whether it's a website that also makes calls. I mean, if we go way back, the website making calls directly to the database, or even when there was a time when we thought we were really doing something special, when the website called a business layer, which then turned around and called the database. I always thought that was a weird model because it felt like there was still this hardening where they all knew exactly what each other was doing. So why not just call the database? Like we've already made the concession that we know what's going on in the data layer. I know that's security folks would come in here and say, no, there's got to be a firewall. And I don't even really disagree with that. But the reason why microservices can be redundant, or easier to be redundant, is that they own their data. So I don't have to worry if something else goes down. I'm up. I'm ready to work.
Yeah.
So drawing those lines, building those fences, and figuring out where to build them is really tricky.
Yeah.
And yeah, go ahead.
Well, that's the $50,000 question, right? How do I split this up? And there's no magic bullet around that. A lot of it, is conversational, and one architect might split it slightly differently than another one might. But in the end, there's general concepts, and we can drop some links into them in the notes here. But thinking around if you look at your application, what are the parts of your domain that those services that can kind of come together in their own specific domain of capabilities, right? We kind of did that a little bit when we talked about that conference app. For things that are conference management related versus ordering, registering versus payment versus customer service, those kind of things, we can separate those out. And it may be that you look at your application's data and it's like, well, I have two big domains here, and that's fine. I think the idea here is that it's easier to split and subdomain than it is to try and go back and put two domains back together, because you realize they kind of belong together. I think we talked, when we were just sitting around earlier about, I've got this domain and every time I update it, I have to update two other domains along with. Well, they probably shouldn't have been separated to begin with, or at least they should be separated a little bit more, because there's something that inherently connects all of those components together. So it is probably the biggest challenge. And I would just, the guidance that I give when I talk about this is that we go slow. We identify, if we've got, an API, let's figure out what are the maybe 3 or 4 components that might be best to group those services into. And does that feel like an appropriate place to essentially start to pull those things apart? And the other thing I always, is what's the part of the microservice that always is a pain point, right? What's that thing that this is why we, it's a monolithic application now. This is why we scale it up. It's because we always run into issues with the product database. We always run into issues with, some other kind of bottleneck. And that may be the first place where you start to see, okay, these sets of services always cause some kind of a constriction of our application to run. So we're going to pull that apart, get that bit of scalability, redundancy, availability, and have that data be its own data so that it becomes less of a bottleneck for your application, hopefully eliminating that part. So that's great. Other things may start to pop up that are your bottleneck, and well, let's go attack them. So that's when you're dealing with a monolith, that's typically how the conversation we have and how customers start to break those things apart.
So here's a definition that says, because people are going to start asking questions like, well, not people. I don't mean necessarily people in the chat. Me.
Sure.
Me is how big is how big or how small is a microservice? And there's something I'm seeing here that says the important point should be to create loosely coupled services so you have autonomy of development, deployment, and scale for each service. And I want to compare that back to what ContriveDX said, because he said, ContriveDX said, deployment. So automated deployment is there.
Yep.
And then when we say autonomy of development, deployment, and scale, I really feel like that word autonomy is own your data.
Yeah.
And part of it is because if it's not autonomous, then you can't update it on its own. You can't deploy it on its own.
Right.
Redundancy leads to scalability, right?
Yeah. Yep. And I think one of the while it might have been where you were going in searching for that autonomous group of, hey, we own this microservice as a development team, and there's probably only going to be 2, 3, maybe 4 people at most that are part of that development team, but they have, they know what the requirements are and what needs to go into that set of services that they're building and maintaining. So there's less reliance on those other microservices. So they have that autonomy saying, we know what this service needs. If you want to call into it, that's great. We're going in this direction. To some extent, right? There's, in the overall view of, hey, this is our application, this is what we're building. But for the most part, they have the ability to define what needs to be built and when from a microservices perspective.
Yeah. And so there's another sentence here, and I think I'll just share real quick so we can see what it is I'm talking about, because it'll be, we don't actually want to look at it too much because that's boring. But
before you do, I do want to say I agree with ContriveDX's thoughts there around what a microservice is. I think it captures a good many of the points.
I was just thinking about comparing it to some of the statements in this article on microservice architecture, which is sitting in Microsoft Learn. I know there's many like this. I think there's like there's several cloud computing sites and so on. But so in here, another sentence that I found interesting is, of course, when identifying and designing microservices, you should try to make them as small as possible. This is what I want to concentrate on. You should try to make them as small as possible as long as you don't have too many direct dependencies with other microservices. Wow. How many is too many? What is too small? What is too big? That's the trick, right? Is I don't know that anyone can sit here and tell you. Direct dependencies, I suppose, harkens a little bit back to what you were saying, that if we think about how, if you just wrote this monolithic front end, the way we used to do it, that was going to look you up as a customer, look you up as an attendee, look up the credit card information, look up your shipping. It was going to do all that from some, maybe it's one database.
Yeah.
That if you have too many dependencies, if I have to send messages or make lookups, which go back and define those terms in a second, with too many other services, am I too blind? Am I too blind? Is that what I mean? Am I too codependent?
Yeah.
Maybe that's a better term, because being blind is not a problem. It's that I'm too codependent on, man, I can't do anything without first going and asking to look up A, B, and C.
Mm-hmm.
And I suppose I use these two terms. I said lookup. Lookup feels to me like calling an API.
Right.
We do that all the time. We call an API to look something up. I know that we also use APIs to actually flip levers, but maybe we favor a message-based system there, where I don't actually want to call a place order API. I'd rather put a place order message, if I can, put a place order message on a queue.
Yep.
And then I don't know what happens. Like, it's just fine. When somebody reads the mail, that's great.
And for most, even though everybody says we need this in real time, nothing happens in real time. You know, there's always some kind of a delay. There's always something that happens that bottlenecks it up. But if having a defined, rigid, or rigid is not the right word. A defined
strong consistency, right?
Thank you.
Yeah.
Well, strong consistency, because when I talk about microservices, I always talk about eventual consistency.
Yes, that's the kind of thing I think we were going.
Yeah, is that okay? All of these services will talk to each other because the message is out there, and the message will persist until, because of the way we've architected, that to make sure that everything that needs to be updated gets updated. When that happens, we will have consistency. So that's the eventual consistency model. And that when we talk about microservices, because each service owns their data, it's going to take time for those things to get updated. And there's some core bits that I'm sure, yes, this data has to be reflected, because when the person goes back to the site and says, hey, here's my latest order, it's showing there, right? And that's fine. That's going to be there. All of the things that happen behind the scenes of, hey, do we have enough product for this? Hey, what's the actual cost for it? Did the billing go through? Doesn't matter. The end user is going to go ahead and look and say, hey, where's my orders? This is my last order. Yeah, that's what I ordered. As long as that happens, everything else can happen behind the scenes and eventually catch up and get that order fulfilled.
Yeah. So,
thank you. I was just about to do that.
So yeah, there's the term. So we just got to that term, eventual consistency, right? Which I've heard that preached before, that the world is eventually consistent anyway, and that we're kind of swimming upstream in a way when we say, like, no, I'm not going to do anything without a lock in the database or something.
Right.
But I feel like there's a companion to that, and it's okay. So the world's eventually consistent, but is your business, and this has nothing to do with technology.
Yeah.
Is your business ready? Like, has your business thought through what happens when somebody shows up, gives you money, leaves, and then you don't have the product. And we have analogies to this, I think, in the real world before there was ever even a computer. Is I could I might just go down to a hardware store and say, hey, I want to buy a hammer and I have $5, and I can plop it down, and then you say, well, let me go back and get it. So I've already given it to you.
Mm-hmm.
You go back and get it. This all seems very quaint, but it's kind of, and then you don't have it.
Right.
So what do? You come back out and you say, yeah, I'm sorry, I actually don't have it. So I'm really sorry. I can give you a rain check. I could put you on a list for later, or I could just say, I'm not going to do that. Why don't you just come back and try again another day? But in any case, here's your $5. So the reason why I want to map this out in like the physical pre-technology world is that the business itself has to have a plan. They can't just leave it to the developers to say like, well, you should deal with that. It should be consistent. It's like, no, what's the business's plan for when anything goes wrong? Because that will lead us to the model of, okay, how will we respond when I go ahead and take the order, but then later some system realizes it can't complete the order, and then it does whatever it has to do to notify you again. It's just really making that analogy back to pre-technology.
Yeah.
And I think too many times you find out that nobody's really thought that through. You just assume it's always going to work, right?
Right.
That's what we pay you for. It's always going to work.
But yeah, I mean, in the end, it's not a technology problem. It's the business continuity problem. What's going to happen? I mean, we have similar kind of conversation. We say, well, what's disaster recovery? How important is this application? How, do we have to make the data redundant in different sites? Do we have to, have a hot and a cold up and ready because it needs to be running that quick, or can it wait 24 hours? It's that same conversation of, in the end, you're running a business, and how important is this to your business?
So do you find that you map out scenarios to help draw the lines? Like, okay, we can all define, we're going to try to do something. We can all define what I like to call I think a lot of us do, but the happy path.
Yeah.
That's easy. And the funny thing about it is so many times we leave the meeting and all we've thought through is the happy path.
Right.
It's hard and it's tiring to think about the error paths, because there are so many of them, especially when it comes to this online, always connected world where every step of the way is a potential sorry, someone didn't hear it or listen, or it died. Every single step of a multi-step process that's internet or network-based. It doesn't have to be internet-based. Once we put two computers together, there's a potential for it not to work.
Yeah.
I mean, I guess there's a potential on our own machines too. We just ignored it.
Before then, yeah.
We just ignored it because it was pretty darn reliable.
Exactly. But I think what you're hitting on is, or at least where I'm taking the conversation, and if not, we can roll back, is, you've got these services that you have in place. What happens when I can't communicate with that service for one reason or another?
Yeah.
And there are architectural patterns that you can put in place where you, and this is one of those conversations that we just kind of came into this and said, hey, let's talk about microservices.
Yeah,
and
but this is more like cloud architecture, like maybe circuit breakers.
It's exactly circuit breakers.
Yeah.
Circuit breakers is the second component. The part before that is, it's how many times it's almost like the try catch, right? How many times am I going to try this API endpoint, this endpoint of a microservice before I say I've had enough? And as I do that, not only am I going to make the first call and it fails, I'm going to wait a little bit before I make that second call. And I may make a third call, and I would probably wait even a little bit longer. And then at that point, all right, I've done 3 tries, I'm done. And then that gets into what you mentioned, that circuit breaker pattern,
right?
Which is,
let's have everybody stop trying. Because like you start with, I think a lot of, and I don't want to say every architecture is going to call it, but like you have exponential back off, where
there you go.
Maybe I'll try because the system might, what we, for lack of a better term, might just call it a hiccup. Let me just try again right now.
Right.
And it's all resolved in milliseconds and nobody knows.
Mm-hmm.
But then when that doesn't work, well, how many times am I going to try before I'm just really DDoSing it?
Yeah.
And so that's, like you said, the exponential back and forth. Well, let me try again in 5 seconds and then 10. And then, okay, I think I might just really declare something's wrong. Somehow it figures out like nobody should be calling this anymore.
Right.
And that's
because you're probably not the only service who's running into this.
Yeah.
So let's tell everybody, hold off.
Right.
Let things settle.
So those are two different patterns.
Yeah.
To improve resiliency. They kind of often come one after the other, but circuit breaker versus exponential backup. That sounds like a whole show, and just resilient application patterns, right?
Yeah, definitely. And that gets into, the patterns of calling other microservices in the environment. That conversation we've touched on a little bit through this around messaging. What kind of messaging do we want? Are we just dropping things on a are we just dropping things on a queue, like that can take many requests at a time and it'll process those as it needs to, or are we doing something a little more enterprise-like, like a RabbitMQ or something like along those lines, right? Where it's more, we want to make sure that each message gets processed and handled and given the attention that it is due, essentially.
Yeah, which is kind of slipping away from microservice, but that's easy to do because the first thing you go to is one, how are we going to keep this thing up after all?
Right. And I wouldn't, it's part of the microservices conversation,
Sure.
but it certainly isn't, it's not the glamorous part.
No, and
right.
I actually think it's the part that concerns me more because I think it's not exciting. No one wants to think about it.
Right.
And when I say no one, I don't just mean your developers and technical folks.
Yeah.
Nobody wants to. Like, who wants to have the hard conversation about, okay, what should the system do if nothing works? Because it's kind of too easy of an answer sometimes. And I know I'm portraying myself as the mean business analyst who's just like, well, it's your job to make sure, like, we should have more uptime.
Right.
It's like, okay, that's cool. We do want a lot of uptime. We want maximum uptime. And then what are we going to do when it doesn't work again? Because there's people's money on the line, or more importantly, how do I unwind something halfway through? If we get to the stage that someone picks up a phone and gets a human on the line, is that person empowered to unwind, figure out, fix? This actually just happened to me today, in fact. It's really a horrible story. I don't mean to embarrass the Boy Scouts of America, though. But several years ago, the Boy Scouts of America must have gone to a web-based system, and I think it's a national database. I'm assuming it has to be. Now, I'm old enough that when I went through the program as a youth, everything was on paper and with carbon copies and in drawers somewhere. So when my daughter enrolled, the pleasant surprise for me was that when I went to enroll her, it actually made me create an account. It didn't, we're talking with youth here, so you're trying to think of the responsible way to do this. So as a parent, I create an account, and to my surprise, the system recognized me. It said, hold on, we know a Chris Gomez with that birth date. Is this you? And it showed me Orange County Council,
wow.
And I was like, so, and there's more to the story, but so you're telling me that they must have opened up drawers and started, how long did that take?
Right.
They've opened up drawers, getting out records and just banging stuff in. It did not have my complete history, but it did have my Eagle Scout date and the date I joined the Order of the Arrow. That must have been what they said, look, that's the minimum. We don't care about the rest of it. Fine. Today, here's the problem. I lived in Southern California. When I signed up, it seemed to kind of figure out that it should join me together. And we are having a heck of a time figuring out how to register me here in Pennsylvania, because the system sometimes it's like, oh yeah, Chester County, Pennsylvania. And then a little bit later, it's like, oh, Orange County, California. And Everything just disappeared. So what I think, and here I am putting on my developer hat,
Right.
is I'm like, I know what happened is no one ever really thought through the process of, we have somebody from the past who we got their records updated on paper and into the database. They might come back.
Yeah.
And not only might they come back now as a parent. So we didn't think about that crossing the streams. And the point of this is that I'm going to have to call some kind of national tech support line because they can't get me registered.
Oh, wow.
And it's not because we're not trying.
Yeah.
It's just that clearly it's mixed up. And what I think is funny here is, so the reason I brought this up is we just talked about, like, so people put a lot of thought and effort into building the system, and now I need a human to unwind it.
Yeah.
So we as developers have to think of those systems.
Oh, yeah. Yeah.
Or do you want to wake me up at 3 a.m. so I can go puttering around in a database? Because I don't want to do that.
And sure, yeah, we don't want to do it, and I'm sure the DBAs don't want us doing it either.
I don't want to do it at 3 a.m. and those kinds of things scare me.
And you talked about the hard conversations around this, and one of the conversations that I've had a couple times with customers is, okay, you're saying I've got my data in one database, and you're saying I've got to split it out across these microservices. Okay, right now in one database, I've got a transact SQL statement that I can now run through and do all of those updates that I'm now splitting out in the microservices. How do I roll that back? Because it's in one database, right? I just roll back the transaction. And there's, long story short, is, just this, much like the circuit breaker, this can be a compensating
transaction.
But if you think about, well, okay, what are the steps that transaction is doing?
Right.
And much like you had, you broke out your services
Yeah.
into those various individual discrete services with their data, you've got to break out that transaction the same way and have essentially a messaging, a type of messaging or eventing to be able to understand, I got through the first 3 steps of this transaction and it failed. I've got to go back and undo those first 3 steps, just like you would in a transaction with rolling back. I've got to go and talk to the database and undo those because this whole transaction failed, and then go send it off to some queue for somebody to figure out, what's going on with this problem. But
yeah,
those are the challenges when you move from one database out to, n number for your services.
So when we had, it's not that we don't have these anymore, but when the whole world relied on transactional relational databases, we just paid the cost of the locking. Transactions by definition have to lock something.
Yep.
Of course, the developers of these databases got better at locking less and less and less. But by definition, and then you as a developer maybe hint a little bit. There's all kinds of tricks we used to use, right?
Right.
But you're now describing a world where, I have to roll back what might be the attendees' information, and that the fact that they're going to this conference, and what if those are separate APIs, and then and so.
And I don't own that data anymore, right? Because the guys who own that service own that.
Yeah. Data. So now I have to tell them, change that. And so, one of the first problems I think can be the word rollback.
Right.
It harkens to a time when we said everybody hold everything, and the whole reason why we went to this model is so that we don't do that. So now and I think I started to say it. If the different way of thinking is so hard, is can you find inspiration in other businesses that have already solved this problem and solved it before computers?
Sure.
Because all we have to do is go to a bank account. The accountants solved this a long time ago because they made a decision a very long time ago that they wouldn't ever erase anything, because that would mean maybe there's fraud if you could erase a line item. Like if we allowed you to come into this written book and erase the $50 deposit, that doesn't sound very safe. So instead, when you make a mistake, you do and this happens today. It happened before there was ever a computer. Is the bank put on the ledger a compensating entry?
Right.
So when the bank in error credits $50 to your account, total error, totally mistaken, then maybe they have to notify you. Who knows? Who cares? But they don't go and remove that off the ledger. They put another entry in that says error, $50 removed. And if you can design your data store in that way, now you can get that win. But there's still a coordination problem, because what if it's multiple microservices, right?
Right. Yeah. You still got to have those services talk to each other.
Yeah. I love how, so true. I love how ContriveDX says WCF, it supported transactions across services. And wow, did we rely on that?
Yeah.
And yeah, there's amazing stuff that we used to just let happen. like begin transaction.
Right.
And it just worked, kind of, I hope. I mean, I guess maybe it didn't just work, because then you had to upgrade the, if I'm allowed to call the SQL Server Big Iron, it just had to get bigger and bigger and bigger. And then it's just, at some point, when you got to internet scale, you couldn't make it big enough anymore.
Right. Yeah. And
And once you need 2, now the whole thing gets very hard.
Yeah, you're on the slope.
Yeah. Although, again, I know there are these really smart people who work on these databases that somehow let you have 2, and there's high availability, and what else was that stuff called? Replication data.
Yeah.
Man, that's crazy. So yeah. Remember WCF. Yeah.
And I know we're kind of getting close to winding down here, and I don't know that we're going to dive into a ton of this, but one of the things we didn't talk about, and one of the things that I personally think is included, it was kind of included a little bit in some of the comments that were made, but certainly not called out, but that DevOps process.
Yeah.
Right. If customers come in all the time, and microservices is the hot thing. It's been the hot thing probably for the last couple of years in conversations we've been having. And the first thing I ask is, that's great, we can talk about that. What's your DevOps process?
Yeah, you turn it around immediately and say there's an issue before you even start.
Yeah, because you're not going to get to the level of redundancy and agility and rolling back and continuous integration and testing and all the things you need to do for one microservices, let alone all of the microservices that you have, if you have trouble just getting things deployed because you don't have a process in place.
Yeah, so if I can, I'll bring this up again.
Okay.
Because there's a bullet point list here. These are always nice for me to look at anyway.
Yeah.
And it includes what you said. So if we go back to the article that was pasted, then what we see here is, let me zoom in a little bit. So this is still in that intro article, and mainly I want to focus on this. The following are important aspects to enable success in going into production with a microservices-based system. So I feel like that's a long-winded way of saying, here's Rich saying, hold on, we can have this conversation, but we better talk about these things first.
Yeah.
Because otherwise, how are you going to go into production? And number 4, well, yeah, kind of. Number 5 was yours, DevOps, CI/CD practices, infrastructure.
Mm-hmm.
But look at some of these other things, really interesting, right? Monitoring and health checks.
Yeah.
Yeah, scalable infrastructure for the services. I guess this is a fancy way of, what did you pick? Did you pick Kubernetes? Did you pick maybe some Azure PaaS services? I think, maybe I'm wrong, but I feel like that's kind of what this is telling you. Go pick something, because you're going to need something.
Right. That service is going to get hit hard for some reason, or a service will get hit hard for some reason. How are you handling it? And monitoring, it is part of that DevOps cycle of being able to make sure that once you deploy, you monitor the health of your application. So,
security design, authentication, authorization, secrets management. I mean, it's so true that really all of this stuff has to be tackled before you go into production, or and I think we said it a little bit before the show, was, I think the main point that I drew out of what you said was, if your software delivery process as a standard, just as a rote rule, takes 3 months, then microservices, you're not ready.
right.
Because what's the point?
Yeah.
Yeah. you might as well just stay, which I'm not criticizing, you might as well just stay in a monolith because you could deliver it quarterly.
Exactly. At least then you've not undertaken additional technical debt of pulling those microservices out and now trying to figure out how to deploy, 5 different services as opposed to one big monolith.
Yeah. Yeah. So that's an interesting idea that before, well, I mean, that's hard because I mean, somebody wants to have the microservices conversation, so you don't want to kind of gatekeep it too much, but it is important to say now before we really embark, your organization has to support several things, and that was a list to draw from, but there's probably other things too.
I mean, once we talk about DevOps and why it's important and all that, we'll certainly talk about microservices because it's a journey, right? The conversations I have are for customers to get them on the journey and be that advisor as they're going down that path. So, it's one before the other, I guess is the way I do it. It's not that we won't talk about it. So we have to make sure we talk about this first and level set around why it's important. And then now that we're in the microservices, they start to see why it's important because of all of the things that we talk about with that list that you mentioned there for starters.
Yeah. Yeah. Well, cool stuff.
Yeah. And it's funny. I don't know if it's just been, end of the year or this new year or what have you, but it's a very popular conversation with customers recently. Just looking at what's coming up for me in the next 6-8 weeks, which is about how far out I schedule some of these talks. Much of January and a good portion of February is all around DevOps and that microservices cloud native architecture as we buzzword talk about it. Mm-hmm. So it's just thought we'd have a
it was very timely,
run and see what see what questions pop up as we start to prep and think about what these conversations are for our customers.
Yeah, it was really timely. And what I thought would be interesting was if you're having a lot of these conversations, I wonder if I could just learn anything just thinking some things through. Because for a lot of us go to work at an organization, and maybe if it's a big organization, we're on a team, and you might be on that team for years. And so that team might do a few things. Let's say that does like 5 things, uses like 5 different technologies or deployment methods or something. So you're going to get really good at those things, but it can be hard. What is kind of nice is if you have the ability to apply it again and again and again to different situations, that probably improves the expertise of, okay, how do you set about designing these things, deploying them? There's nothing wrong with being dedicated to your team. I think that's really good and important, but I often lament that very few of us get to start the new project at a job.
Right.
It's hard, and that's okay. We can't throw products and code away. I've had several jobs where I never would have done file new project. I think from the moment I got there was an existing product, and when I left, there's an existing product, and that was it. And that was years. So now sometimes products evolve and you can learn a little bit from that, but I realize that even though we talk about this stuff a lot, that I feel woefully like just inexperienced in building it from scratch again and again, or at least whiteboarding it from scratch again and again. And it's one thing to maybe like watch a video or read some blog posts, but it's another to be presented with a business problem and solve it, because that's where the rubber meets the road. Mm-hmm. Yeah. If you create your own, and this isn't a bad thing, but if you create your own project to kind of learn from, that's a good thing. But I've always found that those neatly fall into place.
Of course.
And then when you go to work and they say, but guess what? And I'm just going to make something up. But guess what? You did a great job in this design, but it turns out in the hospital, sometimes people have twins or triplets. And, and by the way, they may not they may not have names for the twins or triplets, not just today, but maybe not tomorrow, or maybe not even when they leave the hospital. And you're sitting there, and you as a developer are sitting there going like, wow, this really messes up our beautifully crafted data model where we thought everyone would be unique, but now you're telling me they might not be. This is something that actually has happened.
Oh wow.
It's when it's, and what I mean is it has happened is it was one of those water in the face moments for me as a developer where I really thought I knew a lot about patient data exchange.
Okay.
And then finally a business analyst who was brilliant on the team said, so let me tell you what happens in a hospital sometimes, and related that story. And I was like, wow, we don't handle that at all. Like, you can't even do it. That must be frustrating.
Oh sure.
And I'm now thinking about the customers and the clinicians who are like, wow, you can't do anything. You're hosed because we never thought that you might have. It's one thing to have one child that maybe the hospital staff just calls baby, because they'll do that. They'll just say like Baby Gomez. But now you have 3, and they haven't decided on the name yet. And we're not ready to take Baby Gomez. What do we do? We don't know what to do, and we're going to blow up on them. Like, it's just not going to work, and they're going to hate us. So I think it's a funny story. That's why I tell it. But this kind of stuff happens all the time in the real world. Is now in our fun tutorial example, everything was neat. But in the real world, there's weird stuff.
Somebody winds up getting into the database to fix it. Going back to your Boy Scout
That's
story.
exactly it, though. That's true. All right, everybody. Well, listen, we really happy that you joined us tonight and helped us try out our live show from an after show from Philly.net, Philly Azure. It's interesting that we have like new problems going back from when we all used to just sit at our homes for the last 2 years.
Yeah.
But it is great to be back out again, seeing folks and being in the community. So if you are part of the Philly.net community and looking forward to and just miss the old Philly code camps, there is one coming April 1st, and the Philly.net meetup is the place to go. That'll be exciting to be back here doing that again. But again, you helped us test this out, and it looks like we can accomplish it. And now what we'll have to do is try accomplishing, or maybe we do some coding or deploy some things, and we'll get better at it. So we definitely appreciate everybody's patience and for sticking with us. And if you're watching us in the future on YouTube, then join us every week, Wednesdays at 8:30 p.m. Anything else? Rich is over there.
No, yeah.
Oh, look, it's actually pointing. Yeah, we're actually pointing the right way. Wow, that's cool. All right. Well, let's see if I can.
How that works.
Yeah, let's see if I can figure out how to end the show. We were using some different technologies this last month because we knew we were going to be more on the go. So, I think this works. Yeah, I'm pretty sure. Okay. I think what happens is it fades out and then it goes away. So we'll figure out how to run an end video sometime. But first of all, I just want to thank everybody for being here. Thanks for joining us. Hope we see you next week, where I guess we'll be at our homes, so it'll be a little bit more of the old style. And we'll see you next week on the Dev Talk Show. Ooh. Hold on. See us eventually.